This is chapter 10, number 2. The wording is very hard to understand in this question, but essentially this is what's going on. We have the Earth here. The Earth is here. There it goes. So there's Earth. And when looking at the Sun, that, let's do this. That creates an angle of 0.5 degrees. And they are asking the rate of the Sun. Well, we know that that the angle is 0.5 degrees. Distance, or the radius, if this is a circle, goes all the way around, then what cuts through the Sun is the arc length. So this is the arc length. It says whenever you have an angle that's less than 15 degrees, the difference between the arc length and the chord, the actual distance between this point and this point, or displacement, is pretty much the same thing. It's very close to being the same thing. It's less than 1% difference. So it's okay to consider this as the diameter. If that's true, then the arc length divided by 2 will give us the radius of the Sun. Okay. So let's redo this equation. Arc length is the angle times the radius of this circle, the huge circle, Earth, where Earth is the center. And if we plug that in here, we get the angle times the radius, or the distance for the Sun, divided by 2 will give us roughly the Sun. We know the angle is 0.5 degrees. We need to change that radians. This is what I got. I took this and I multiplied it by 57 because 1 radian, or actually I didn't multiply it, I divided. 1 radian is 57.3, so if I divide it by 57.3, it gives me this long number all the way through. Now, the distance was in kilometers, so I had to change that to meters. First I put it in scientific notation, and then I changed it to meters, 1.5. Plugging the numbers in, you get that the radius of the Sun equals 654450225 meters. Keep it in significant digits, and yet 7 times 10 to the 8 meters. This is the same thing as 7 times 10 to the 5 kilometers. Now, if you look at the book, the book tells us what the actual mean radius is. of the sun. They say that the actual radius of the sun is 6.96. Whee! That was fun. Let's fix that. .96 times 10 to the 5 is a 10 kilometers. So we actually were pretty spot on. This is really impressive because if we know the distance of anything and we know the angle that is subtended, then we can figure out the radius of the object or the length of the object. So very interesting stuff. Why is it different? Why is this 7 and this 6.96? Or why did we get why did we get 6.5 times 10 to the 8 meters? Remember that they said that the angle was about 0.5 degrees, so that was partly off, and the distance was also kind of rounded up. So that's it.